Write the distance of the point P2, 3, 5 from the xy plane. So let's take the xyz axis. Consider this is x-axis, y-axis and z-axis. All the three axes are mutually perpendicular to each other, and the point 2, 3, 5 is located. So 2 units on x-axis. So this is origin. So 2 units along x-axis, positive direction of x-axis. Say this is L. So here is a point 2, 0, 0, and then 3 units of y coordinate. So parallel to y-axis. So we can draw a line 3 units. So this is 3 units. Say M is the point. So M is a point on xy plane. So that point can be considered here with x coordinate 2 and y coordinate is 3. On xy plane we can consider z coordinate is 0. So 2, 3, 0. And then the point z coordinate is 5. So which will be taken parallel to z axis. So parallel to z axis we can consider 5 units. Say this is the point P 2, 3, 5, which is taken the length PM is equal to 5 units. So here OL is equal to 2 units, x coordinate, and y coordinate, that is LM parallel to y axis, is 3 units, and then PM is perpendicular. So here we will consider 5 units. So any point, distance of the point, say x, y, z from the xy plane is equal to mod z. Mod z units we can, that means the modulus of the z coordinate we can consider. So here the distance is the required distance from the point 2, 3, 5 from the xy plane is mod of 5, that is 5 units. Okay. Write the distance of the point P3, 4, 5 from z axis. Let us consider the xyz plane. X-axis, y-axis and z-axis, all the three are mutually perpendicular to each other. So let's consider the point of intersection is origin, and the point 3, 4, 5 is located. So we consider 3 units on x-axis. So let us take L is the point such that OL is equal to 3 units. So L can be considered the point 3, 0, 0, because any point on x-axis is x coordinate and y coordinate, z coordinate will be 0. And the next y is equal to 4. Let us consider draw the parallel line to y-axis of length 4 units. Say this point is M. So we have 3, 4, 0, because on xy plane z coordinate is 0 and x coordinate is 3 and y coordinate is 4. And then to get the point 3, 4, 5, take 5 units which is drawn parallel to z axis. So let us draw the line parallel to z axis through M perpendicular to LM. So this is 5 units. Say here the point P 3, 4, 5. And now the distance between the point from z axis. So from z axis the distance is same as from O to M. So the distance we can consider which is same as O to M. Here is the distance. the perpendicular distance from the point to the z-axis will be the same as distance from origin to the point 3, 4. So it's nothing but distance origin is 0, 0, 0, or we can just consider here 3 and 4, it's a right angle triangle. So basically we can say that distance of the point x, y, z from z-axis is equal to root over x square plus y square. So here required distance, so distance of the point 3, 4, 5 from z-axis is equal to root over 3 square plus 4 square. The distance between the origin and the point 0, 0, 0 and 3, 4, 0 is also, we can say 3 square plus 4 square plus 0 square, that is 3 square plus 4 square, or by using the right angle triangle we can consider. So which is nothing but 9 plus 16, it's a root 25, so which is of 5 units. So the distance is 5 units we can consider. Okay. If the distance between the points a, 2, 1 and 1, minus 1, 1 is 5 units. So here P, Q distance is given 5 units. And we know the distance between the 2 points, say A, x1, y1, z1 and B, x2, y2, z2 is given by AB is equal to under root of x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. So we need to find the value of A such that the distance between P and Q is 5 units. So we can write here, since the points P, A, 2, 1, point Q, 1, minus 1, 1. So let's consider to be x1, y1, z1 and x2, y2, z2, so that we have distance root over x2 minus x1 whole square, that is 1 minus a whole square plus minus 1 minus 2 whole square plus 1 minus 1 whole square is equal to 5 units. Or we can squaring on both sides. So we can add 1 minus a whole square plus negative 1 and negative 2 is negative 3 whole square, and 1 minus 1 it is 0 square, which is equal to 25. Or we can add 1 plus a square minus 2a plus 9 is equal to 25, or a square minus 2a, and here 1 plus 9, 10 plus 10 minus 25 is equal to 0, or a square minus 2a and minus 15 is equal to, 10 minus 15, so 10 minus 25 is negative 15, which is equal to 0. So we can just factorize it now. A square minus 5a plus 3a minus 15 is equal to 0. So a taken common, so a minus 5 plus 3 times of a minus 5, which is 0. So we have a plus 3 into a minus 5 is equal to 0, that is a plus 3 is equal to 0, or a minus 5 is equal to 0. So we can consider a is equal to minus 3 or a is equal to 5. So these are the two values, either negative 3 or positive 5. The coordinates of the midpoints of the sides AB, BC and CA of triangle ABC are D1, 2, negative 3, E3, 0, 1 and F negative 1, 1, negative 4 respectively. Then write the coordinates of its centroid. So take a triangle ABC. Vertices are ABC and the midpoints of the sides AB is given D with coordinates 1, 2, -3, and midpoint of BC is given E, that's a 3, 0, 1, and the midpoint of AC CA is given as F, -1, 1, -4 respectively, and so that we can also consider the triangle which is formed by joining the midpoints. So DF triangle will have the centroid is same as the centroid of triangle ABC. So we can write here centroid of triangle DF. That's the midpoints. These are the midpoints of ABC. Triangle ABC. Centroid of triangle ABC is same as centroid of triangle ABC. Centroid of triangle DEF is same as the centroid of triangle ABC. So centroid of triangle DF is so we know the formula for centroid is x1 plus x2 plus x3 by 3 y1 plus y2 plus y3 by 3. Centroid formula x1 plus x2 plus x3 upon 3 comma y1 plus y2 plus y3 upon 3. For triangle DF we can consider x1 y1 z1, x2 y2 z2 and x3 y3 z3. So we can write 1 plus 3 plus of -1 divided by 3 comma, so z coordinate 5 items, z1 plus z2 plus z3 by 3. So 2 plus 0 plus 1 upon 3 and -3 plus 1 plus of -4 upon 3. So we can add 1 plus 3, 4, 4 minus 1, that is 3 upon 3, comma, 2 plus 1, it is 3 upon 3, comma, minus 3 plus 1 is -2, -2, -4 is -6 upon 3. So which is 1, 1, -2. So 1, 1, -2 is the centroid of triangle DF, and also we can say centroid of triangle ABC also same. So centroid of triangle ABC is same as centroid of triangle DF. Centroid of the triangle which is obtained by taking the midpoints, that's a DF, which is equal to 1, 1, -2. Okay. Write the coordinates of the foot of the perpendicular from the point 1, 2, 3 on y-axis. So let's consider the coordinate axis. X-axis, y-axis and z-axis. Set origin, and the point 1, 2, 3 is located. Say L is the point, 1 unit, 1, 0, 0 on x-axis, and then y coordinate is 2 units. So take a line parallel to y-axis of 2 units, so that we can say here 0, 2, 0 is the point on y-axis, and then the point z coordinate is 3 units. So from here say M, so take a line perpendicular to xy plane, the positive direction of z axis, 3 units. So here is a point 1, 2, 3 is located in the plane. Then the coordinates of the foot of the perpendicular from the point on y-axis. So we can consider from here the perpendicular can be considered on y-axis. This is the perpendicular we can just consider on y-axis. It will be found exactly at the point 0, 2, 0. So we can say the foot of the perpendicular. Say this is n. N is the foot of the perpendicular. From the point 1, 2, 3 on y-axis is 0, 2, 0. Generally we can write coordinates of the foot of the perpendicular from point x, y, z on y-axis is 0, y, 0. So here we can say that point on y-axis is 0, 2, 0. Its y coordinate is 2 units. So you can say 0, 2, 0. Y coordinate is 2, so 0, 2, 0. Okay. Write the length of the perpendicular drawn from the point 3, 5, 12 on x-axis. So first let us consider the point on coordinate axis. X-axis, y-axis and z-axis, and the point is given 3, 5, 12. So 3 units in positive direction of x-axis from origin. Say L is the point 3, 0, 0, and then 5 units parallel to y-axis in the positive direction of y-axis. Say here 5 units. Say the point is M. So it is a point on xy plane. So 3, 5, z coordinate will be 0, and then take 12 units towards the positive direction of z axis perpendicular to the xy plane. So we can get say here is a point 3, 5, 12 with the length of PM is equal to 12 units, and now we need to find the distance of this point on x-axis. So distance of this point from x-axis which is taken, this PL is perpendicular. We can say PL is perpendicular, which is same as here perpendicular to the sides. We can say PL square is equal to LM square plus PM square, or PL is equal to under root of LM square plus PM square, that is LM distance is 5 units, so we can write 5 square plus PM distance is 12 units, so that is 12 square. So we have 5 square is 25 plus 12 square is 144, so which is 25 plus 144 is 169, square root of 169 is 13. So therefore we can say that the length of perpendicular from point 3, 5, 12 on x-axis is 13 units. Or in general, we can also write, length of perpendicular from point x comma y comma z on x-axis is given by root over y square plus z square. So we can say simply root over 5 square plus 12 square, that is 13 units. Okay. Write the coordinates of the third vertex of a triangle having centroid at the origin and two vertices are 3, minus 5, 7 and 3, 0, 1. So let the third vertex be, let us consider third vertex of triangle be alpha, beta and gamma such that, say this is the vertex C, such that triangle ABC whose centroid is origin 0, 0, 0, say O, where the point A, where let us consider point A is 3, minus 5, 7 and B is the point 3, 0, 1. Since we know that the centroid formula is x1 plus x2 plus x3 by 3, y1 plus y2 plus y3 by 3, z1 plus z2 plus z3 by 3. So here we can write centroid origin is given 0, 0, 0, which is equal to 3 plus alpha upon 3, minus 5 plus 0 plus beta upon 3, 7 plus 1 plus gamma upon 3. So we can write 3 plus 3, that is 6 plus alpha. 6 plus alpha upon 3 is equal to 0 and beta minus 5 upon 3 is equal to 0 and 8 plus gamma upon 3 is equal to 0. So we can write 6 plus alpha is equal to 0, beta minus 5 is equal to 0 and gamma plus 8 is equal to 0. So we can write alpha is equal to minus 6, beta is equal to 5 and gamma is equal to minus 8. Therefore the third vertex is minus 6, 5, minus 8. What is the locus of a point x, y, z for which y is equal to 0 and z is equal to 0? We know that any point on x-axis is of the form x, 0, 0, that is y coordinate is 0 and z coordinate is 0. Therefore, we can consider locus of a point x, y, z for which y is equal to 0 and z is equal to 0 must be lies on x-axis. So we can say that the locus is x-axis. Find the ratio in which the line segment joining, so there's 2 points, say point P 2, 4, 5 and point Q 3, minus 5, 4 is divided by the xz plane. So let us consider this is a plane. It's an XZ plane. This plane, these 2 points, the line segment joining these 2 points is divided by the plane. Let us consider the point to be R. And we know that in XZ plane, the points will be of the form whose y coordinate will be 0, say x comma 0 comma z. Let R x comma 0 comma z be the point on XZ plane which being divided the line joining divided the line segment PQ. Let lambda is to 1 be the ratio of R divides PQ. So let us consider lambda is to 1 ratio. So by the section formula we have, and its y coordinate is 0. Since y coordinate is 0, we will take the only y coordinate. So we have lambda times of y2. So we have lambda y2 plus 1 times of y1 divided by lambda plus 1 is equal to 0. That is lambda times of y2 coordinate is minus 5 plus 1 times of y1 coordinate is 4 upon lambda plus 1 is equal to 0. So which implies that minus 5 lambda plus 4 which is equal to 0, since the denominator cannot be 0. Lambda plus 1 cannot be equal to 0, so we consider the numerator 0. So we have 5 lambda is equal to 4, or lambda is equal to 4:5, which is positive. So we can consider lambda is to 1 the ratio. The required ratio is nothing but lambda is to 1 is 4:5. So 4:5, that's the internal ratio we can consider. Okay. Find the point on y-axis which is at a distance of root 10 units from the point 1, 2, 3. We know that any point on y-axis is of the form 0, y, 0, since x coordinate and y coordinate are 0. So let us consider the point. Let the point on y-axis be 0, beta, 0, such that PA is equal to root 10, where A is equal to 1, 2, 3. So by using the distance formula, squaring on both sides, we have PA square is equal to 10, and we know the distance between the 2 points x1, y1, z1 and x2, y2, z2. Distance between the 2 points, say this is P and Q. PQ is equal to under root of x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. Similarly here, PA square is equal to 10, or PQ square means we can remove the root. So PA square is equal to 1 minus 0 whole square plus 2 minus beta whole square plus 3 minus 0 whole square is equal to 10, where we can say this is x1, y1, z1, and here x2, y2 and z2 applied. So 1 square plus 2 minus beta whole square by using a minus b whole square, 2 square is 4 plus beta square minus 2ab, that is minus 4 beta, plus 3 square is 9, which is equal to 10. So we can write beta square minus 4 beta plus here 1 plus 9 10 and here 10 gets cancelled. So here remains only plus 4 equals to 0. So which implies that it is in the form of beta square minus 2 into beta into 2 plus 2 square is equal to 0, just like a square minus 2ab plus b square is 0, so that is beta minus 2 whole square is equal to 0. So getting two equal roots, so beta is equal to 2 we are getting. Therefore point on, we can say the required point on y-axis such that PA is equal to 10 root 10 units is 0, 2, 0. Find the point on x-axis which is equidistant from the points A 3, 2, 2 and B 5, 5, 4. So we know that any point on x-axis whose y coordinate and z coordinates are 0. So let point on x-axis be alpha, 0, 0, whose y coordinate and z coordinates are 0, such that it is given that it is equidistant from the points A and B. Say this is P. So PA is equal to PB. Or squaring on both sides, PA square is equal to PB square. So there is a point P, alpha, 0, 0, and there are 2 points A and B. It's given that the distance between P to A and P to B both are same. So by using the distance formula, if 2 points are given, A x1, y1, z1 and B x2, y2, z2, then we have the distance formula is AB is equal to under root of x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. So by using this distance formula, we can write PA square means we can remove the root and we can just write down P, and A is the point P alpha, 0, 0, and A is the point 3, 2, 2, and B is the point 5, 5, 4. So PA square is alpha minus 3 or 3 minus alpha, let me write 3 minus alpha whole square plus 2 minus 0, that is 2 square, plus 2 minus 0, that is 2 square is equal to, and here 5 minus alpha whole square plus 5 minus 0 whole square, that is 5 square, plus 4 minus 0 whole square, that is 4 square. So we can just simplify, 3 3s are 9, 3 square is 9 plus alpha square minus 6 alpha plus 4 is equal to 5 square is 25 plus alpha square minus 10 alpha plus 25 plus 16. So upon simplifying, alpha square on both the sides with a positive sign will get cancelled, and here 4 plus 4 8, 9 8 17. So we can bring here minus 10 alpha here, plus 10 alpha, minus 6 alpha, plus a 17 over here, and the remaining minus 25 and minus 16 is equal to 0. 10 alpha minus 6 alpha is 4 alpha, and here it comes 17 minus 16 is 1, and here it comes 1 minus, this is 50, this is 49 we can write. So minus 49 is equal to 0. So alpha is 4 alpha is equal to 49. So which implies that alpha is equal to 49 upon 4. Therefore the required point on x-axis such that PA is equal to PB is 49 by 4 comma 0 comma 0. Find the coordinates of a point equidistant from the origin and points A comma 0 comma 0, B 0 comma B comma 0 and C 0 comma 0 comma C. So there is a point P which is equidistant from origin. Origin says 0 comma 0 comma 0 and point A, that is x-axis, A comma 0 comma 0 and point B on y-axis 0 comma B comma 0 and point C on z-axis 0 comma 0 comma C. So let point P be, let the point P be x comma y comma z such that it's a distance from O to P same as P to A and O to P is same as P to B and O to P is same as P to C. So let us use OP is equal to PA or OP square is equal to PA square by using the distance formula, and between the points origin O 0 comma 0 comma 0 and point P x comma y comma z and point A comma 0 comma 0. So we will get OP square is nothing but x minus 0 whole square, that is x square, and y minus 0 whole square, that is y square, and z minus 0 whole square, that is z square, is equal to distance between the PA is a minus x whole square, or we can write x minus a whole square plus y minus 0 whole square y square and z minus 0 whole square z square. So upon simplifying, so here y square and z square with the same sign gets cancelled on both the sides. So we have x square is equal to, here we can simplify x square minus 2ax plus a square. So again we can cancel here x square with the same sign gets cancelled. So 2ax is equal to a square, or we can write x square is equal to a square upon 2a, that is a upon 2. So we got the x coordinate is a upon 2. Similarly OP is equal to PB is a point, that is OP square is equal to PB square. So by using the distance and origin O 0 comma 0 comma 0 and point P x comma y comma z and point B we can write 0 comma B comma 0. So we have OP square is equal to PB square, that is x minus 0 whole square, that is x square plus y square plus z square is equal to distance between P and B will be taken x minus 0 x square plus y minus B whole square plus z minus 0 whole square, that is z square. So we can cancel here x square and z square. The remaining y square is equal to y minus b whole square, that is y square minus 2by plus b square. So upon cancellation y square with the same sign, so we will be getting again y is equal to minus 2 or 2by is equal to b square, which implies y is equal to b square upon 2a. So that is b upon 2. Here getting y is equal to b upon 2. Similarly if I take OP is equal to PC, that is OP square is equal to PC square O origin 0, 0, 0, and point P x, y, z, and point C 0, 0, C. So we can add OP square is nothing but x square plus y square plus z square, and PC square is nothing but x square plus y square plus z minus c whole square. So as usual we can cancel here x square y square with the same sign both the sides. So z square is equal to, so z square minus 2cz plus c square. So again we can cancel this z square and z square. So we have 2cz is equal to c square, or we can add z is equal to c square upon 2c, so which is c upon 2. So finally we got the point. Therefore the required point Px, y, z is nothing but a by 2, b by 2, c by 2, such that it is equidistance. OP is equal to PA is equal to PB is equal to PC. Okay. Write the coordinates of the point P, which is 5/6 of the way from A to B. So let us consider the point A minus 2, 0, 6, and the point B 10, 6, negative 6, negative 12, and point P is located in such a way that it's a 5/6 of the way from A to B. Let the coordinates of point B, let the coordinates of point P be x, y, z. So given that PA is equal to 5/6 of the way from A to B, that is 5/6 times of AB is given, or this can also be written PA is equal to 5/6 times of PA plus PB, or we can write PA is equal to 5/6 times PA plus 5/6 times of PB. Upon simplifying, PA times 1 minus 5/6 of PA is equal to 5/6 times of PB, or we can write this is 1/6 times of PA is equal to 5/6 times of PB. So we can cancel and we can write PA by PB is equal to 5/1, which is given PA to PB is given in such a way that it's a 5:1 ratio. It's a 5 parts and 1 part. So by using the section formula, it's an internally division. So PA is to PB is equal to 5:1. By using the section formula, we can write point x, y, z, which is given by mx2 plus mx1. We have the formula mx2 plus mx1 by m plus n. Similarly for the y coordinates and z coordinates. So we can write here m is equal to 5 and n is equal to 1. So 5 times of 10 plus 1 times of minus 2 divided by 5 plus 1, that is 6, 5 times of negative 6 plus 1 times of 0 upon 6, 5 times of negative 12 plus 1 times of 6 upon 6. On simplifying, 5 times 10, 50 minus 2, that is a 48 upon 6, minus 30 plus 0, it's a negative 30 upon 6, it's a negative 16 plus 6. Negative 16 plus 6 is nothing but minus 54 upon 6. which is equal to 6 8 times, 6 5 times, negative 5 times, and 6 minus 9 times. So we can consider the point to be 8 comma minus 5 comma minus 9. So the required point is 8 comma minus 5 comma minus 9. Okay. If a parallelepiped is formed by the planes drawn through the points 2, 3, 5 and 5, 9, 7 parallel to the coordinate planes, then write the lengths of the edges of the parallelepiped and length of the diagonal. So let's consider parallelepiped. In three-dimensional geometry, say this is x-axis, y-axis and z-axis, that is the origin, and the 2 points are given on the different opposite planes, parallel planes we can say. So let us consider here is the point A is the point 2, 3, 5, and let us consider the point B on the opposite plane B such that it's a 5, 9, 7 on 2 parallel planes. So that we need to write the lengths of the edges of the parallelepiped and length of the diagonal. Since the point is 2, 3, 5 and the other point is given here 3, 5, 9, 7, clearly if we can just observe here along the x-axis the coordinates. So considering the plane, thinking about the plane, the first through the point D and through the point A, whose x coordinates are here x is equal to 2 we can say, and here x is equal to 5. So the distance between these 2 planes is nothing but the difference between them. So the length of the edges of the parallelepiped are along x-axis. Along x-axis length can be taken mod of 5 minus 2, that is 3 units, and along y-axis let B is equal to, so y-axis means we consider the planes along to the y-axis. So take this plane whose y coordinate is 3 and considering the plane here passing through the point D whose y coordinate is 9. So the difference between them along the y-axis, the difference is nothing but mod of 3 minus 9 or 9 minus 3, so we'll be getting 6 units. And then along z-axis along z axis, say height h is equal to, so let us consider the planes, the top and bottom. So the top one is passing through the point B whose z coordinate is 7, and the bottom is passing through the point A whose z coordinate is 5. So we can consider that h is equal to mod of 7 minus 5, which is equal to 2 units. So the lengths of the edges of the parallelepiped are 3 units, 6 units and 2 units. And the length of the diagonal, so we can say the diagonal AB, consider the diagonal AB whose length is given by using the distance formula, under root of x2 minus x1 whole square. So we consider the point 5 minus 2 whole square plus 9 minus 3 whole square plus 7 minus 5 whole square, which is equal to 5 minus 2 is 3 square is 9, 9 minus 3 6 square is 36, and 7 minus 5 is 2 square is 4. So under root of, so which is equal to 36 plus 4 40 plus 9 49, so which is equal to 7 units. So we consider that the lengths of the edges are 3 units, 6 units, 2 units and 7 units. 3 units, 6 units and 2 units along the edges, and diagonal is equal to 7 units. Okay. Determine the point on YZ plane which is equidistant from points A 2, 0, 3 and B 0, 3, 2 and C 0, 0, 1. So we know that on any point on YZ plane whose x coordinate will be 0. So let the point P be any point on YZ plane, say P 0, beta, gamma, such that PA is equal to PB is equal to PC, or we can also write PA square is equal to PB square is equal to PC square. So with the points here P 0, beta, gamma, A is the point 2, 0, 3 and B is the point 0, 3, 2 and C is the point 0, 0, 1. So by using the distance formula, PA square is nothing but 2 square plus beta square plus gamma minus 3 whole square, and PB square is nothing but 0 plus beta minus 3 whole square plus gamma minus 2 whole square, which is equal to, and PC square is nothing but 0 plus beta square plus gamma minus 1 whole square. So upon simplifying, we may get 4 plus beta square plus gamma square plus 9 minus 6 gamma, which is equal to beta square minus 6 beta plus 9 plus gamma square plus 4 minus 4 gamma, which is equal to beta square plus gamma square minus 2 gamma plus 1. That is beta square plus gamma square minus 6 times gamma plus 13 is equal to beta square plus gamma square minus 6 beta minus 4 gamma plus 13, and here beta square plus gamma square minus 2 gamma plus 1. Now let us consider first and the second one. So we have beta square plus gamma square minus 6 gamma plus 13 is equal to beta square plus gamma square minus 6 beta minus 4 gamma plus 13. So we can see that beta square gamma square with the same sign gets cancelled, and also 13 also with the same sign. So we have minus 6 gamma, and here minus 4 gamma will come here, plus 4 gamma is equal to negative 6 beta, or we can write minus 2 times gamma is equal to minus 6 times beta, or we can just write gamma is equal to 3 times of beta. So this is an equation 1, and we are now considering first and the last one. By taking the first and last, so we have beta square plus gamma square minus 6 gamma plus 13 is equal to beta square plus gamma square minus 2 gamma plus 1. Upon simplifying, so beta square gamma square with the same sign gets cancelled, and we can write here minus 6 gamma plus 2 gamma is equal to 1 minus 13, that is minus 4 gamma is equal to minus 12. So we can write gamma is equal to minus 12 upon negative 4 is 3. So we got the value of gamma is equal to 3. So put gamma is equal to 3 in equation 1. So we'll get 3 is equal to 3 beta. So which implies that beta is equal to 1. Hence the required point is, hence the required point on YZ plane is, so on YZ plane is, we can say x coordinate is 0, 0 comma, y coordinate is 1 and z coordinate is 3. So 0 comma 1 comma 3 is the point such that PA is equal to PB is equal to PC. Okay. If the origin is the centroid of a triangle ABC having vertices A comma 1 comma 3, B minus 2 comma B comma minus 5, and C 4 comma 7 comma 6, sorry C, then we need to find the values of ABC. We know that centroid of triangle ABC whose vertices are A x1 y1 z1, B x2 y2 z2, and C x3 y3 z3 is given by x1 plus x2 plus x3 by 3, y1 plus y2 plus y3 by 3, z1 plus z2 plus z3 upon 3. So here the three vertices are given, A 1 comma 3, B minus 2 comma B comma minus 1, C 4 comma 7 comma C. So we can write centroid of triangle ABC of given triangle ABC is equal to A plus of minus 2 plus 4 upon 3 comma 1 plus B plus 7 upon 3 comma 3 plus of minus 5 plus C upon 3, and which is given in the problem origin is the centroid 0 comma 0 comma 0, which is given in the question. So we can consider if two ordered places or two ordered triads are equal, the corresponding elements are equal. So we can write A plus of minus 2, that is A minus 2, A minus 2 plus 4 upon 3 is equal to 0, 1 plus B plus 7 upon 3 is equal to 0, 3 minus 5 plus C upon 3 is equal to 0. So which implies further A plus 2 is equal to 0 since 3 cannot be 0. So which implies A is equal to minus 2, and here B plus 8 equals to 0, which implies B is equal to negative 8, and here c minus 2 is equal to 0, which implies c is equal to 2. So we got the three values. A is equal to negative 2, B is equal to 8, negative 8, and C is equal to 2. This is the answer.